Ray tracing. Ray tracing is a powerful geometric tool used to locate and characterize the images formed by optical surfaces. So basically, we'll just have to trace the rays so that we can locate and characterize the images. So, asa man nato magamit ang ray tracing? We can use it on concave mirrors, convex mirrors, and plane mirrors. Basically, sa mga things na mo reflect. And then these is the parts of the ray diagram. And then we have here ang kining dotted lines that is called our optical axis. However, optical axis is commonly used in lenses, not mga terms. Since this is a mirror nga topic, so ang kining optical axis is likely to be used as principal axis. So ang kining optical axis is more or less principal axis. It's not optical axis, it's principal axis. And then we have here R, which stands for the radius. Radius because this is diameter. Ang kininalinya is diameter, half ana is ang radius. And then let's have a continuation for the parts of the ray diagram. We have the CFV. C stands for the center of curvature because tunga siya sa circle. But sa pag-drawing na to sa ray diagram, it will only be this side and not the whole circle. And then we have the F for focal point, and then V for vertex, or it can be P per pole. So sa last video, pole ang gigamit adto. So if V ni siya or P, that is just the same. And then C can also be termed as 2F because this is 1F and this is the second F. So kaduhaon ang F, 2F. And then let's start with concave mirrors for this topic. And then we have the reflecting surface, which is in the inner part. As we know, ang concave is cave. So, ang kinina part, ang ato gina-examine ani. Ang reflecting surface ana. Kay mirror man ta, reflecting. And then for this example sa spoon nato, of course, ang kining na inverted ang ato i-take as example for these concave mirrors because this image here on the right side is convex mirror, which will be discussed later on. And then concave mirrors is actually converging systems. If ang ato concave lenses are diverging, ang concave nato is the opposite, converging system. And then since it is a converging system, it possesses the plus power and converges light. So if you want to have a quick overview for the concave for the mirror versus lens, so here it is. So nganong opposite ang mirror sa lens. So opposite sila because of the action of light basically. So mirror, since it is reflection, it bounces off the light. And then for the lens, it has refraction in which the light passes through. So ang mirror and lens is opposite tungod sa ila action of ila pagtake sa light. Let's start with our concave mirror. So assume we have Shrek here as our object and he is placed beyond the center of curvature. So unsa may image aning ato Shrek nga rin na object using the ray tracing. So we have here the first ray trace. So we have the parallel ray in which you have to draw an incident ray that is parallel to the principal axis. As ang principal axis, ang kining dotted line. This whole dotted line is our principal axis. From the tip of the object and straight to the reflective surface. So tip ni Shrek and then padong straight. And then next is this parallel ray leaves the object parallel to the optical axis and reflects directly through the secondary focal point. So basically, ni hunong kang ray kanina and then imo na i-target karon kay mo lahos ka aning F. So that is parallel ray. And then next is we have the vertex ray. So you have to draw an incident ray that directly hits the vertex of the mirror. Thus the name vertex, because it igo the vertex from the tip of the object and straight to the V. And then you have this in which ang vertex ray nato is ni follow siya sa law of reflection. So naatay incidence nga rin, angle of incidence, and angle of reflection. And then we have the focal ray. So sa panganian na focal ray. Draw an incident ray that passes through the focal point and straight to the reflective surface. So basically, imo ra ni iigo ang F, nya draw ka nga raog line originating from the tip of the object to the F. And then the reflected ray bounces back in the front of the mirror. So mo straight na sad siya. The ray is now parallel to the optical axis or the principal axis. Then we have the straight ray passes through the C, striking mirror perpendicular to its surface, which is 0 degrees incidence, and then causing it to bounce straight back along its original path. So ang light ani kay padung na siya padung adto, unya mo balik ra sad siya padung anhi. So basically nagbalik-balik ra siya ang straight ray. And then we put this all together, ang kining four diagnostic ray lines nato, which are the parallel, the vertex, and the focal ray, and the straight ray. And with this all together, it creates an image. So you can actually use 2 or 3 rays lang, then maka-create na siya og image. But if you want to be a perfectionist, and this discussion is for illustration only, and ako lang gipakita ang mga ways sa kining different types of rays para makahibaw ka kung unsaon jud ang paghimo aning sa image using the ray tracing. And then now that we have the image of our Shrek here, how do you describe the image? So by describing the image formed, the image is described in terms of the following. We have the location, the orientation, size, and type. So basically, it's lost. Shrek is lost. Where is he lost? So first is the location. So we have the following choices. It can be between F and V, or the focal point and the vertex. At F, pwede sad nga ra ang image. Between F and C, at C, and beyond C. So ang kining sa ato Shrek anhi kay nabilong siya sa between F and C, or the between focal point and center of curvature. And now for the orientation, we have upright and inverted. So as you can see, nabaling nga rin si Shrek. So ang sa may pasabatan na, inverted siya. Nanong makahibaw ka if inverted siya or upright, pwede raman siguro na to i-rotate ani si Shrek para ma-upright, diba? No, it cannot be. Because for an object to become upright, it should be above the parallel axis, the principal axis. Para ma-inverted is dapat below siya sa principal axis. And then for the size is naatay reduced or diminished, enlarged or magnified, and the same size as the object. So sa kining ato image, kay ato siya i-compare sa size sa ato object, which is mas dako nga rin si Shrek, ang original nato na Shrek. So meaning ang kining image na na-form nga nihi kay that is reduced or diminished because it is smaller than our object here. And then for our type, we have 2. We have the real and virtual. So since the image of our Shrek here is inverted. So ang inverted is always paired with real, and virtual is always paired with erect. So since kuan man ng ato Shrek nga ri, inverted, he is real. And also, makaingon sad ta ni real if naa siya anhi mismo. If behind na siya sa mirror, which is naa na nga rin na area, kini na area, that is where we will consider it to be virtual. And if virtual na siya, automatically erect rasad na siya. Therefore, when an object is placed beyond the center of curvature of a concave mirror, the image formed is between C and F, inverted, reduced or diminished, and real. So, regardless if si Shrek pa na or other objects, basta kay beyond na siya sa C, mao jud ni implementi ang mugawas nato na image formation. And then, how about if ato i-move si Shrek nga ri sa C? So, the image formed is at C, na siya sa C, no? Nagkuan na siya, naglinya na siya. And then, the same size as the object, same na sila og size, inverted, and real. By applying the principle of the different rays kanina, so we can see here, so pwede ko nimo i-draw. Then we have here the first ray, which is the parallel ray, so ang kining red. And then the yellow, which is our vertex. The green, which is our focal ray. And then the blue, which is the radial ray, katong mo igo sa center of curvature. So as you can see, align jud siya dapat sa C lahos kay, so at C jud ang formation ani because naman jay ray na matrace na straight jud sa C. And then let's move again our Shrek here. So what if the object is between C and F? So the image formed is beyond C. So gawas na siya sa C. Mas dako na siya karon sa object, mas dako na ni karon na Shrek compared sa object nato. And then inverted siya because naman siya sa obos sa principal axis, and then it is also real. Or in other words, ang ato image kay real, it is because naa siya in front of the mirror. Again, real basta in front of the mirror. If behind the mirror, that is virtual. And then what if the object is at F? So the image formed is at infinity. There is no distinct image. There is no image formed. The reflected rays are parallel. So nga nung wala man di image formation, basta naa siya exactly at the focal point. That is because ang kining radial ray nato ug ang kining parallel ray nato is never na sila mag-meet. Kay parallel man sila. When we say parallel, they don't meet each other at endpoint. Then what if the object is between the focal point and the vertex? So the image formed is behind the mirror. It is enlarged or magnified, erect, and virtual. So mo na ni karon. Ang ato naman linya nga ri kay nag-assume naman siya na pina-diverging. So naa diri karon ang endpoint. Paana na siya og porma because ang kini ng mga rays dili na siya mag-meet. So ang paghimo ani sa image karon is behind na siya sa mirror, and when it is behind the mirror, that would mean nga erect or virtual siya, and it is also magnified. Okay, next, what if the object is at V or at the pole? So since na naman siya nga sa vertex, so object is equal to the image, and the image is formed at V, the same size as the object, and it is erect and virtual. Nganong erect and virtual siya because same raman siya og unsay stance sa kining object. And since the object is above the principal axis here, so of course erect and virtual siya, so mag-assume siya na mura siya og convex mirror. And then here is a summary for the image formation on concave mirror. Feel free to pause the video so that you can review this. So yeah, if maglisod jud ka og kanang visualize, so it's better siguro na mag-familiar na lang ka ni, or kung napakay time mag-memorize. Okay, let's proceed with the convex mirrors, in which ang reflecting surface is in the outer part. So, ang kininap na part. And then, sa spoon na to, dili na ni mao, kay walay inverted image sa ato convex mirror. So, this is our convex mirror sa ato spoon. So, convex mirrors are diverging systems. So, opposite siya sa ato concave mirror. It possesses the minus power and diverges light. So, now, you will have to shift your perspective. The parts on the optical axis is now on the other side of the mirror. They are considered to be virtual. An apostrophe is added to the symbol. So, as you can see, na apostrophe ang ato focal point, ang ato center of curvature here. So, that would be considered as the second. And then we have here an example. So, parallel ray. So, ang ato object here is located between the C and the F. So, what would be our image here? So, you have to draw an incident ray that is parallel to the principal axis. So, di same ra gihapon siya og principal sa ato concave mirror. However, kini karon is ni taas na siya. Align the reflected ray to the focal point inside the mirror. So, you will have to align this line to the F. If nagbutang ka nga ri og linya, unsaon man na nimo pag kuan, di man na siya makaigo sa F nimo. So you will have to draw it like this so that makasud ang kini na broken lines padong sa ato focal point anhi sa sulod. And then focal ray, draw an incident ray that is pointed, directed to the virtual focal point. So again, this is the virtual, and then this is the real. So focal ray, the reflected ray bounces back parallel to the principal to the optical axis. So, focal ray, muigo ra gihapon siya sa F, pero naay mo reflect na light parallel. And then, sa kadtong na parallel na line, magdraw na sad kag another set of dotted lines in which diri ang image formation mismo. Dili siya sa kini na linya, but kini nga linya. So, medyo complicated ang focal ray, no? So, you will have to extend the reflected ray towards the inside of the mirror. And then we have the straight ray. So, straight lang yun siya. Draw an incident ray that is pointed directly to the virtual center of curvature. And then the incident ray is also reflected ray, so the arrow has two arrowheads. So same gihapon kanina na mo padong anto nya mo balik rasad siya reflection. So now we have the three ray na ato na trace. So putting all together, we have the parallel, the focal, and the straight ray. And then this is our image. So naa siya belong sa virtual, wala siya sa ato real anhi. So meaning to say, it is behind the mirror. So now that we have these three ray traced, how do you describe the image? So the image is described in terms of the following. So we use the taog lost na mnemonics. So location is between the virtual focal point and the vertex. The orientation is erect because it is above the principal axis. And then size is diminished and type is virtual because naa siya sa behind the mirror. And then we have the summary for the image formation and convex mirror. So again, you can pause the video so that you may review. And as you can see, it is always erect and virtual ang ato convex mirror. Bisan pa og asa na ang object location nimo. And then for the third type of mirror, we have the plane mirrors. So it is flat, meaning to say it has infinite ranges of curvature. And when it has infinite ranges of curvature, it does not change versions of light, meaning to say it has power of 0. So how do we visualize this? So basically, kung unsay mo object, mausad ang imo image. So same size, same erect and virtual, same as object ang image size, image location is exactly the same, distance behind the mirror, anywhere in front of the mirror. So basically, if 5 cm ang image location, if 5 cm ni siya, ang imo sad image distance nga rin 5 cm. So bali more or less equal. So ang plane mirror ang pinaka best na mo follow gid sa law of reflection. Okay, now that we're done with the three types of mirrors, we actually have a website that can give you an image characteristic for you to better visualize what it looks like to have the ray tracing. So this is what it looks like to have the concave and convex mirrors. So we'll just have to move this, and then again, let's have a summary. So if beyond siya sa ato C, muna ang ato C kini center of curvature, CC ang gibutang aray. So if that's the case, our image here is smaller than the object. It is diminished or magnified. It is inverted and real image. So muna move man din. Okay. Move jud siya. Chuya. And then if naa siya sa C na to, exactly at C, medyo lisod si butang sa C mismo. Basta if exactly C siya, kaya nga to image is naasad siya sa C, and then they have the same size. If between siya sa center of curvature and focus, as you can see, mas dako permanente ang ato image kaysa sa object. No? Oh, muda ko jud siya. And then, if exactly at the focus siya, or the focal point, as you can see, parallel na ang ato ray tracing anhi. So meaning, walay image formation. Let me just lisod siya i-exact. Pwede ba ni ma-edit? Okay, dili siya ma-edit. Okay. So, wala siya image because parallel siya. And then, what if our focal point here, what if ang ato object is between the focal point and the V? So, as you can see, ang ato image kay naa na behind the mirror. No? And mas dako ang image. So, magnified siya. So, muna siyang itsura. And then, if anhi, ngari sa 0, so, upright siya, virtual image. So, basically, the same with the object. That's for the concave mirror. And now, getting past here, we have the convex mirror. So, As you can see, no matter where, no matter asa ni siya, ang ato image nga rin, kay it is always smaller than the object. No? So mo nang makita ka sa kanang sa side mirror sa car na ay makabutang kadto na objects may appear smaller or farther away than in reality. So this is the reason why. So as you can see, no? Sag-asa pa na siya nya halos dili siya mo abot nga ri sa focal point. So if infinity na gid siya, maybe dira na mo igo siya sa focal point. However, sa kini na ato illustration here, dili gid siya mula pa sa ato focal point. No? Okay. Again, if beyond the center of curvature minified, if on the CC ang image is nasa CC, if nanhi kay magnified ang image, focal point no image, between is na siya sa behind sa mirror, meaning to say kuha na siya virtual and direct. If on the V is equal 0 0, and then sa convex mirror is ang ato image is always virtual and direct and smaller than the object. Mirror and magnification equations. While a ray diagram may help one determine the approximate location and size of the image, it will not provide numerical information about image distance and object size. This means that our discussion kanina of ray tracing is more about the qualitative side. Now, to obtain the type of numerical information of this image distance, the object size, it is necessary to use the mirror equation and the magnification equation. This is to get the quantitative side of this information. Now, what is the mirror equation? We have here the 1 over f is equal to 1 over object distance plus 1 over image distance. While the magnification equation, we have the m is equals to image height over object height, which is also equivalent to negative image distance over object distance. So depende kung unsay given nga ra, basta ang magawas aning kini na equation and this equation is just the same, just that magnification siya and ang iya unit is x or times or magnification, magnified kung pila ang iya ratio in terms of the image. And then let's use this diagram so that we can fully visualize what this equation is all about. If mugawas bagyod ang ato f nganhi sa kining given nato. Now, what is this focal length? Okay? What is this focal length? So focal length muna siyang basically the distance between this vertex or the pole to the focal point, which is ang sa kini kay 4. But assuming wala pa ta kay balo kay lagi wala dili man siguro ta magdrawing, let's just use this equation first. So 1 over do plus 1 over di. So let's just simply substitute. So 1 over f is equal to 1 over ang ato do is 6 plus 1 over 12. So bring your cycles with you and let's answer 1 over 6 plus 1 over 12. So that is 0.25. 1 divided by answer because we want to get the f value itself, not the reciprocal value. So the answer would be 4, and then we got the answer of 4. So sakto nakuha ra dayon. If you want another way na makakuha ani, pwede ra sad ta mo gamit og kining exponent na -1 because that is also 1/10 nga value. So 6 to the power of negative 1 plus 12 to the power of negative 1. That is also 0.25. And then 0.25, which is the answer, then raise it with the negative 1, so your answer will still be the same. So depende ra gyud na nimo kung asa ka comfortable, if sa fraction ba or imo ba siya imano-mano og divide. That is okay as long as we arrive with the same answer. That is totally fine in the world of math. Okay, now we're done with the mirror equation. Now we will proceed with the magnification equation. So magnification equation is more on the ratio, right? So let's have this hi and ho. Hi-ho. So m is equals to hi, which is negative 4, and then ato ho, hi-ho, so it is negative 2 times. So importante ang negative because this indicates nga ansa inverted ang ato image. So pasabot ang kining ato object nga ri, object height nato, which is pila 2. Yes, that is 2, is ang kining image height nato nga ri is negative 4. So ang kining negative 4 is negative 2 times larger than this object height. So di ba make sense ra siya? 2 times negative 2 is equals to negative 4. So twice as big ang kining image height. And then let's compare it with this negative di over do, if same ra ba siya og gawas. So let's say di is okay, negative 12 over ang ato do 6, which is still the same, negative 2 times. So magnification is negative 2 times. So you've arrived with that answer, and now we've proven that the mirror equation and magnification equation are correct. Let's proceed. So we have the plus and minus sign conventions. The sign conventions for the given quantities in the mirror equation and magnification equations are as follows. So if ang ato focal length is plus, that is a concave because a concave mirror is a converging system. And then if our f naman is minus or negative, so mirror is a convex because convex is a diverging system. And then for the image distance, if plus na siya, that means that the image is a real image and located on the object side of the mirror. So that means na ato di is padong anhi, which is of course real because that is in front of the mirror. And then if negative, of course ang opposite, which is virtual and is located behind the mirror. And then for our image height, if plus siya, image is an upright image and therefore also virtual, as I've said. If virtual na gani na siya, of course erect na siya dayon. And then if negative naman, that is also an inverted image, therefore also real. So hand in hand ra gid na sila. So that's why our magnification equation here is also hand in hand rasad na sila. Okay, let's have an example. So a 4 centimeter tall bulb is placed a distance of 45.7 centimeter from a concave mirror having a focal length of 15.2 centimeter. Determine the image distance and the image size. Okay, so if you want, you can actually draw this. So a 4 centimeter tall daw, so that is our object. So you can like draw it like this. Okay, 4, and then is placed at a distance of 45.67 centimeters from a concave mirror. 45.67 is very far compared to the 4 centimeters, so ako iglayo yun siya. And then having a focal length of 15.2 centimeter. So given ra ang ato focal length, so nara siya around anhi ato focal length. So layo, medyo layo gid ni siya ko ano light bulb. So we can assume na siguro siya outside sa ato center of curvature, because focal length, if ato ni 2 times 2f is equals to CB, center of curvature. So 15.2 times 2 is 30.4. So we can assume na ang C nato nga is nara anhi around. So sa pag ato to i-apply ang ato learnings kanina sa ray tracing, if ang ato object is beyond C, that means that the occurring or the resulting image will be inverted and diminished, as well as being real, kay tungod inverted siya. And now since ko naman ta get over naman ta atong sa ray tracing, ato ra gi-apply nga rin para murag makita nato if sakto ra to man answer later on. So let's solve it in a numerical way. So here it is. The given is our object height, which is 4 centimeter, and the object distance is 45.7 centimeter. Our f is 15.2 centimeter. So we must determine the image distance and the image size. So what would be the first step? That is to determine the image distance using the mirror equation. Nganong mirror equation? Because naa diri nakabutang ang ato di. So given man ang ato focal length og ang object distance. So simply substitute lang and you will arrive with the answer of 22.78 centimeter. And then now that you have the image distance, you can now find the image height. So to determine the image height, the magnification equation is needed. So nanatay image distance nga rin, so ma-substitute na siya except for the image height which we will be looking for. So simply substitute, anya ato lang gi multiply both sides by 4 centimeter mo nang naana diri karon ang 4 centimeter sa other side. So 4 ianhi siya. Anya don't forget the negative sign here, and that's why our image height here is negative 1.99 centimeter. So nganong wala man nga ri ang magnification, because wala man gi pangayo nga ri image distance and image size raman. So this means nga ang ato focal length being 15.2 centimeter, that is a plus, bisan wala gibutang nga ri, it is a concave because it is a converging system. Padung man siya sa ato. And then sa kining sa ato image distance, since it is plus 22.78, okay, nag-una siya nga rin. So ang ato image height is negative 1.99 cm. Being negative, that means nga ubos siya sa principal axis nato, na siya sa ubos. So that means inverted siya. And then since our image distance is naa siya padung anhi, naa siya in front of the mirror, that means that it is real, given by the sign convention of plus, and then image height of being negative is na dapat lang di lang gid na kalimtan. Okay, example 2. A 5 cm tall light bulb is placed at a distance of 13 cm from a concave mirror having a focal length of 15 cm. Determine the image distance, image size, and magnification. So, sa kinina example, makadraw ta og 5 cm na sad na light bulb. Anya, ang distance daw niya, concave gihapon ta, is 30. It's 30. Focal length is 15. Since ato 2f is 30, since 15 times 2 is equals to 30, so nakinakitaan, di ba? Ang kalayon niya kay the same as the C. So we can say nga ang ato object distance here is the same, na siya at the C. So mag-expect ta na ang image ani according sa ato gidiscuss kanina will be placed at C also with the same size, just that inverted siya. So same, mag-expect ta ani na ang magnification kay 1 times because they will be on the same size because it is located at C. So if nakalimot ka, pwede ra gid kay na mo balik ang video para makaingon ka na wala ra ko nag himo-himo ang regstorya. Okay, let's prove it in a numerical way. So the given is ang ato object height is 5 cm, object distance is 30 cm, and focal length is 15 cm. Now we are going to find these variables or the values of these things. To determine the image distance, the mirror equation must be used para makita ta sa image distance. Then substitute the values and you will arrive at the value of plus 30 cm. Okay? And then to determine the image size, the magnification equation is needed. So yeah, you will just have to use this, and then you will arrive at the image height of being negative 5 cm. And then, since our f here is plus, that is a concave, negative 5 cm of image height is inverted, and the image distance of plus 30 cm is being a real image because it is in front of the mirror. And then, let's not forget the magnification. Kaya kibangayo na karon nga ri sa example 2. So m is equals to hi over ho. So that is negative 5 kini, and then 5 cm. So negative 5 over 5 would result into pilaman negative 1 times. So naa siya negative because ni invert man ang image. So that stands correct, and yeah, correct ra ang ato gi-explain kanina. And then you can also use the kining negative di over do. So 30 cm over 30 cm, so that is also negative 1 time. So bisan asa ning duhay mo gamiton, mo gawas ang magnification of negative 1 times. Okay, let's proceed to example 3. Inverted image is magnified by 2 when the object is placed 22 cm in front of a concave mirror. Determine the image distance and the focal length of the mirror. To visualize this, ato ni siya hinayon. So, inverted image, unya natay clue nga ri in front of a concave mirror. So, concave ni siya na example na sad. Yang ato object nga ri is placed 22 centimeter, and then our image is magnified by 2. So twice siya. Now we can't really find this manually, so we need to really solve for this. So how do we solve for this? So given is magnification is negative 2 times, and then object distance is 22 cm. So ang ato nahon, since na naman tayo do og m, so makapangita ra ta ani through magnification equation. Okay? So m is equals to hi over ho, and then it is also equal to negative di over do. Since wala may given nga rin na object height or image height, we will use the negative di over do. So given na ang m na negative 2 is equals to negative di over 22 cm. So simply substitute, mo arrive ka og image distance of about plus 44 cm. Now, to determine the focal length, the mirror equation must be used. Since na naman tay do and di, pwede na nimo siya is substitute freely. And then, you will arrive at an answer of f is equals to 14.67 cm. And that would be the example for the mirror equation and the magnification equation.
Anti-reflection coatings.
Fresnel reflection. Every transparent surface performs a dual role. It transmits light, allowing you to see through it, and reflects light, acting like a weak mirror. So kung nakay makit-an or nakay kasugat na naay glasses, unya makit-an nimo na naay reflection, that is actually Fresnel reflection. Especially if uncoated, wala siya mga anti-reflective coatings. So mas makit-an nimo ang Fresnel reflection. So as the refractive index of an optical material increases, the amount of light reflected off its surface increases as well. For light rays striking a transparent surface perpendicularly, we calculate the fraction of reflected light, or R, using the Fresnel reflection formula, which is here. So R is equal to parenthesis N1 minus N2 over N1 plus N2 parenthesis, then square that. So where our N1 is our refractive index of the first medium, usually it is air if unspecified, N2 is the refractive index of the second medium or the lens material. So let's have an example here. So for our R2 CR39 plastic, so what is the Fresnel reflection of this CR39 plastic? So we can simply substitute the formula of Fresnel reflection. So yeah, you will just have to substitute. So N1 is our 1 and then N2 is 1.498. So ipangbutang lang anha, and as you can see, ang difference anong nila dapat nga repermente is always 2 because you subtract here and add here. That is if ang ato N1 is 1 ang gamit. Pero if given ang N1, of course, mulahi sa dang ila difference. And now we have arrived with our R here being negative 0.199 squared. So since squared man siya, ma-eliminate na ang negative, bisan pa rin mag-cycle na siya, mawagya pa ng negative. So our R here becomes 0.0397 or 3.97%. So we can say here na sa CR39 plastic, which has an index of refraction of 1.498, it has a Fresnel reflection of 3.97%. So mo bounce back siya og light of 3.97%. So that may be the reason na ay reflection sa usa ka ay glasses na CR39. So how about R2 polycarbonate? So as we know, polycarbonate has an index of refraction of 1.586. So the same what we have done with the CR39 plastic, we'll just have to substitute the values. So let me just correct this. This is not 0.199. This is supposed to be 0.227. So this is supposed to be 0.227 squared. And now we will arrive with the same answer here, which is the R is equals to 0.0513 or 5.13%. This means that the more na ay index of refraction ang ato material anhi, mas higher ang index of refraction, that means that more ang ma-reflect. So mas importante ang AR coating or anti-reflective coating sa mga high index na materials because mas ilamang good i-reflect ang light. So reduced light transmission, a typical spectacle lens has two surfaces, the front and the back. The total transmission is approximately T total is equal to 1 minus R front times 1 minus R back, where T total is the total transmission and R is the reflected light sa katong ato formula kanina kung unsay nakuha nato na R. So let's continue with the CR39 plastic, which is 3.97% ang iya katong Fresnel reflection. And then we can simply substitute the total transmission formula here, which is 1 minus R front. What is our front? That would be the 3.97%, so ang decimal form, as well as for the back. And then you will arrive with the answer of total transmission being 92.22%. So bali, ang pasabutan ni, only 92.22% of light is being transmitted through the CR39 plastic. So ang kining formula nato na 1 minus r, so we can actually make this T total. Okay, let me just change sa, okay, baga ra kay siya. T total is equal to 1 minus r squared. This is assuming that front and back are at the same nga Fresnel reflection value. Sa kini man gud na given nato, since mag-assume man ta na CR39 plastic siya sa front and the back, so same ra gihapon siya og makuha if kini na formula ang imo gamiton. So whichever ang imo mas comfortable gamiton, so you are free to do that. And then let's continue with the polycarbonate, which is the 1.586, 5.13% kanina ang R, and then the total is 90% transmitted. So as you can see, mas dako og transmitted light ang ato CR39 compared sa ato polycarbonate. That's why mas mo reflect og light ang ato polycarbonate. That's why need jud siya og AR coating. As you can see here, higher refractive index, the more the reflection. That's why high index lenses such as 1.67, 1.74, so mas taas, mas grabe ang reflection. These need AR coatings more urgently. They reflect 7 to 9% per surface. So that is approximately like 14 to 18% if total. So like 100 minus 18, that is about 82% transmission. So that is very gamay na lang na light, no? And yeah, mas reflected na kayo, so mas maayo na na-adjud tay AR coating. And then how do we identify the ideal coating index for perfect cancellation, zero reflection? The two reflected rays must also have equal amplitude. This requires just the square root of the lens index. So mo na siya ang ato equation, NZ is equals to square root of the end lens. Okay? So for example, here a standard CR39 lens requires a single layer anti-reflection coating. What will be the ideal refractive index of the coating? So you will just have to square root the index of refraction of this CR39. So you will get an ideal coating index of 1.22. This is called ideal coating because this is a zero reflection. But in practical use, there's no such thing na maabot siguro og 1.22 na siguro na siya sa about mga 1.33 and above depending on the material. So wala jud perfect nga coating index nga maka completely 0% ang reflection. So that's why bisan pa og mga high-end pa na siya ng mga eyeglasses, kay naagihapon na siya reflection kung imo na siya isagad nga do sa suga. So let's have an example applying those three equations that we've discussed earlier lang. So a patient is prescribed a pair of high index 1.67 plastic spectacle lenses for a high myopic correction. If the lenses are completely uncoated and light strikes the front surface perpendicularly, what is the total percentage of light transmitted through both surfaces to the patient's eye? So is it A, B, C, D? So you may pause this video if you want to answer. So ang ako lang gusto na makitaan is ang katong sa R nato, ang sa ato T total and kining NC. Nagngayo ba og NC ngari wala day? Okay, wala din NC pero pidirasad ka mo pakapin nga NC para ma-practicead ka. Okay. Let's answer. So first is our Fresnel reflection. So simply substitute lang and you will arrive with an R being 6.3%. This means nga na ay 6.3% nga reflected. And then for the T total, so simply substitute lang yapon na naman tayo R nga rin na value, and then you will get an 87.8 transmitted light lang sa ato 1.67 na plastic. So gamay ra siya, no? Kung mas dako jud siya og index of refraction. And for our ideal index sa coating kay 1.29. So have you got it right? So I hope so, because we'll now proceed with the benefits of anti-glare and anti-reflective coatings, which are it reduces the reflections, reduces eye strain, aesthetically pleasing. So mas lindot siya kataon kay Of course, wala na yung reflection kaayo. And then, improving visibility. Ikaw mismo, kay dili na ka maglisod og tanaw since mas daghan na og light na ni-transmit ngadto padung sa imuha. And then, health benefits because it reduces eye fatigue. So, hand in hand na sila. Okay. So, why AR lenses look purplish? So, naay mga AR lenses nga kung ikuha nimo siya sa light kay purple siya og color. So, in basic or single layer AR coatings, engineers optimize the thickness of the thin film to target 589 nanometers, which is the wavelength for yellow light. This is chosen because human daytime vision is maximally sensitive to the yellow-green band of the spectrum. So if naa ka sa tunga-tunga, which is the yellow to green na band, that means nga imo left out ang short wavelengths and the longer wavelengths. So that means nga ang ato blue ug ang red nga ri kay magmix. So when this blue and red mixes, it will create a purplish. That's why our AR lenses, especially if basic or single layer, will look purplish. However, there are cases nga ang ato AR lenses will look bluish or greenish. So modern premium lenses don't stop at one layer. They use multi-layer AR coatings stacked like a sandwich. So mas daghan ni siya og layer of AR. So the green or blue reflection on the glasses is the color of the remaining 1% or lesser pa kaha. On the lenses of the glasses, the anti-reflective coating could not eliminate. This reflection is also known as the bloom. So if makita ka og bluish or greenish nga reflection, that usually means nga premium na siya na lenses.
Purkinje Images.
Purkinje Images, also traditionally referred to as Purkinje Sunsun Images or catoptric images, represent the reflections of an external light source bouncing off the four primary optical interfaces of the human eye. So, why is it called Purkinje Sunsun Images? Because the pioneer for these Purkinje Images are John Evangelista Purkinje and Louis Joseph Sunsun. John Evangelista Purkinje is Czech, Czech, and then Sunsun is a French. Starting with Purkinje Image 1, which is situated at the anterior cornea. So as you can see here, if makita nimo na siya, kini, morning, anterior cornea. Then the interface is air to cornea boundary. So air, ang ato light wala ni light kay air to cornea boundary. So the nature of that is virtually direct because the surface here is convex. And then brightness is, it is the absolute brightness of the four reflections. Why? Because this occurs of the refractive index leap from air to corneal tissue. It is the largest index shift encountered in the ocular pathway. So compared sa other, pag kunyari sa P2, sa P3, and sa P4, ang P1 ang pinaka-brightest because of the difference of the 1 and the 1.376. And then this Purkinje Image 1 is also known as the corneal light reflex, which is used in the Hirschberg. So, nganong makaingon man ta na brightest siya? It is because ato to apply ang ato learnings kanina sa katong Fresnel reflection. So, ato lang siya substitute sa ato mga values ani unya magpakita nga rin ang R nato is equal to 2.5%. That means nga ang ato Purkinje Image 1 mo reflect siya og 2.5% of the light that is being received. So mo nang if mag Hirschberg ka or magsuga ka og light nga sa imong pasyente is naa gyud nay mo reflect nga light. That is our Purkinje Image 1. Mo din ang imong makitaan. And then clinical applications also include the keratometry and the Hirschberg test. Okay. Proceeding with the Purkinje Image 2, which is situated at the posterior cornea, na siya nga rin. So, the interface of this Purkinje Image 2 is that it is the cornea to aqueous humor boundary. So, another ocular media na sad, aqueous humor. So, nature and orientation is virtual and direct because, again, it is a convex surface, and then the brightness is dimmer than the Purkinje Image 1 because of the index difference being smaller than katong kanina na 1 og 1.376. Karon kay 1.376 to 1.336, which accounts for 0.02 2% reflectance. That is very gamay lang. And then since this is situated ang kining Purkinje image to duol ra gini siya sa ato P1 because ang cornea kay thinner man na siya. So ang kining Purkinje image 2 is often overlapped by this Purkinje image 1. So ang imo makita na Purkinje image 1 ang sa nga yan na tabunon permanente ang image 2 superimposed. Then next is Purkinje image 3 or situated in the anterior lens. So here is the lens. Okay, P3. So kini. This is also a convex gahapon siya. So the interface is aqueous humor to anterior crystalline lens boundary. So another optical media. So the nature and orientation is virtual and direct because it is a convex surface. And then dynamic property is that this is geometrically the largest image. So if na question what is the Purkinje image that produces the largest image, the answer would be the Purkinje image 3. Crucially, its size changes dramatically during accommodation. So since ang lens man gyud nato kay mag-change man siya size kung mag-accommodation, so as the ciliary muscle contracts and the anterior surface of the lens bulges forward, decreasing the radius of curvature, the Purkinje 3 shrinks in size and physically migrates closer to the cornea. So, in other words, the more na ako nang accommodate ang usa ka mata, mo gamay ang image sa Purkinje 3 nato. And then next is Purkinje image 4, which is situated at the posterior lens. So, kini. So, compared sa P1, which is convex, P2 also convex, P3 is also convex, ang P4 na to, which is on the posterior side, is a concave na. So that means nga ang iya nature and orientation will become real and inverted. So the structural identity is that because of the posterior lens surface curves inward relative to the incoming light, it acts as a concave mirror, while the first three convex surfaces scatter rays outward, forming virtual upright images. This concave boundary converges the light rays, forming a real inverted image in space. So, ni connect ragad ang ato mga discussion kanina pa. And then, if ang question gani kay what is the Purkinje image that produces the smallest image, that would be the Purkinje image 4. Munang pinanggamay mo hatag image. And then this is the summary for the characteristics of the Purkinje images. So we have here nagpakita nga rin na ang 4 ang real and inverted ra, and then ang anterior cornea is the brightest while the 3 and 4 are the dimmest. And as you can see here, mo na siya ang location nato in respect with the corneal apex. So ang Purkinje image 1 nato is situated siya sa 3.9 mm and then sa 2 kay 3.8 mm. Nya makita nimo nga rin na ang sa 3 na to, Purkinje image 3, it is the largest. So, no? Dako jud siya. Unya ang ato 4 mo ay pinaka smallest, pinakagamay. Sorry about that. And then as you can see, mo na siya ang itsura sa ato Purkinje images. And then that would be all. And if you are really interested, pwede ra gid ka mo adto sa annual quiz if you want to take practice and all. So please do visit para ma-practicean ka. And then I would like to extend my thank to everyone who is watching right now. Thank you very much for spending your time to learn with me, to listen to me if nag-listen ma jud. And then all right. And then we have these references that I have used for this presentation. So we have here mostly from kining na libro, kining geometrical and visual optics sa clinical introduction 3rd edition. So nga rigid ko mismo nag-base. So yeah, that would be it. Thank you very much and bye.